Let's talk about a tool you may have seen in your science classes called dimensional analysis. That's method A, where we use kind of this crosshatch pattern where we say you multiply by everything on top and divide by everything on bottom. Whereas part B, we're multiplying fractions. Now they get the same answer. Why do they both work? The idea here is something from Math 2010. They both work because of two reasons. One, fractions are division. One way we define a fraction is saying that A over B is the quantity that results when we say we take A divided by B. And two, the commutative property. I can think of these fractions as being moved around to be 25 times 100 over 1 times 1 over 1 times 1 over 1 times 1 over 1, and then times 1 over 1 to get the denominator from the first conversion factor, times 1 over 2.54 times 1 over 12 times 1 over 3. Notice I'm separating numerators and denominators to make it so multiplication comes first and division comes second. These are the same process, just thought of in slightly different ways. Now, let's look at the fractions we multiply by in method B. There's something special about them. These are all known conversion factors, but remember, one way we think of conversion factors is as an equal exchange, that 1 meter is equal to 100 centimeters. In terms of value, in terms of changing the length of an object, these fractions are, in a sense, equal to 1 because they divide equal things. This is important. When we use proper conversion factors, we are not changing the length. We're multiplying by a bunch of ones. What we're changing is how we view the length. That's what I'm trying to go here with B and C is this recognition is that the fractions are equal to 1. Now, let's use what we did in the last one to convert meters to yards. Let's see. We first want to go meters to centimeters because our main metric to American conversion for length is 2.54 centimeters equals 1 inch. Well, to go from meters to centimeters, I have to cut up. So I'm going to do 25 times 100 first. Now, to go from centimeters to inches, well, centimeters are smaller than inches. I have more centimeters taking up the same space as 1 inch. So if I want to make a bigger unit, I have to divide because I'm gluing things together. I'm trading something of smaller value for something in higher value. So I need to divide by 2.54 to go from centimeters to inches. Similarly, when we go from inches to feet, we have to divide by 12 because I'm gluing together my inches to make feet. And finally, when I go feet to yards, I divide by 3. Let's look up at dimensional analysis. We did 25 times 100. There's a bunch of ones on top, so we don't use them, divided by 2.54, divided by 12, divided by 3. Dimensional analysis is additionally an expansion of our thinking on when do we multiply, when do we divide. Now, let's convert 1 mile to kilometers using the fact that 1 inch is 2.54 centimeters. You can do any method, it actually asks us to do dimensional analysis, so let's do that. So I need to somehow get from miles to inches. Well, I don't know how many inches are in a mile, but I know how many feet are. Now I'm cutting this up into smaller pieces, and so I should be multiplying by 5,280 feet per mile. Remember, another thing with dimensional analysis is this idea of canceling out variables or dividing out units. That's because that helps us recognize how the exchange rate works. I'm getting rid of miles and exchanging for feet. Similarly, I'm going to get rid of feet and recognize that there in 1 foot, there are 12 inches. So the unit I'm getting rid of goes on the bottom. And now I'm ready to get rid of inches. I know that in 1 inch is 2.54 centimeters. So notice I'm multiplying all these because I'm going to smaller and smaller unit sizes, meaning I need more of them to cover the same distance. Now I'm going to go the other way. I'm going to glue together my centimeters to make meters. There's 100 centimeters in 1 meter. And that's going to get rid of my centimeters. And then I want to get rid of meters. And I know there's 1,000 meters in 1 kilometer. And now I have something where I can multiply a bunch of stuff and divide a bunch of stuff. It follows our idea of multiplying by fractions that equal 1, as well as our idea of we multiply when we're cutting units up and dividing when we're gluing them together. So I'm going to do this on a calculator off screen. Let's see, I have to do 1 times 5,280 times 12 times 2.54 divided by 100 divided by 1,000. And this tells me that when all is said and done, that 1 mile is equal to 1.609344, and I'm sure there's more decimals in there. Or actually, no, that is completely accurate. Kilometers. So if any of you ran track in high school, you may feel cheated because because a 1,600 meter is actually 9 meters short of exactly a mile.